Hello. In this video, we want to look at the following. We have the demand function for a certain product is given by P equals 50,000 minus Q all over 25,000. Find the marginal revenue when Q equals 10,000 units and P is in dollars. Okay, so here's the thing. The demand function is just telling us at some quantity supplied, what should we charge the price of, or what will the price be? That's found in a different way. We're not going to talk about that right now, at least. But what we need to talk about is the revenue, because that's what we're worried about for now. We want to know, how do we find revenue? Revenue as a function of the price, P, or in this case, Q, the quantity supplied. It doesn't really matter. It's going to be one or the other. Now, in this case, because we are actually supplying something, we want it in terms of Q. So to do so, let's go ahead and realize, how does a company make money? A company makes money by selling something of some sort, or product, some sort of product, some service, something, product or service. I think does that cover everything? I think so. Anyway, here's a question for you. If I sell you 30 hot dogs, and every hot dog was $2 a piece, how much money should you give me? You very likely said $60. Why? Because you had $2 a piece, and there were 30 of them. What did you do? You multiplied them. The price times the quantity. That's all revenue is. It's price times quantity. So it's the price times the quantity. But notice that we know P in terms of Q already, so what I can do is I can replace this P with this entire thing right here. That's the fantastic thing about this. So the revenue as a function of the quantity would be this 50,000 minus the Q over the 25,000 times Q. Now notice that I can go ahead and divide these. So instead of doing it like this, we could have made this 50,000 over 25,000 is just 2, and then minus 1 over 25,000 Q. That's the exact same thing. So this would be 2 minus 1 over 250,000 Q times Q. Now, how did I get that? I just did the division. 50,000 divided by 25,000 is 2, then minus 1 over 25,000, so 1 over 25,000, and then the Q in the numerator can just go out front. Now, notice that this Q would need to distribute here, and that's going to give me the revenue as a function of the quantity supplied. That's going to give me 2Q minus 1 over 250,000 Q squared. Good. And the question is asking us to find the marginal revenue when Q equals 10,000 units, P is in dollars. Okay, so what is R prime of 10,000, basically? Well, to get there, we found out what is R prime of Q. Well, we're going to take the derivative of this. Notice that there is an understood 1 right here. It comes down in front. 1 times 2 is 2, making that 2. And the Q goes away because 1 minus 1 is 0, so there are no more Q's for that term. Now for the next one, 2 comes down in front. 2 in the numerator over 250,000. There's a common factor of 2, making that minus 1 over 125,000. Now Q to the 2 minus 1 is 1. So that's Q to the first power there. Good. So this is the marginal revenue as a function of the quantity supplied. Notice that this is a linear function, and that the y-intercept is 2, and the slope is negative 1 over 125,000. Because it's a negative slope, that means at some point the marginal profit will be negative. We'll talk more about that a little bit later. But for now, we just want to know, what is the marginal revenue when Q equals 10,000? In other words, we want to find R prime of 10,000. So just plug in 10,000 for Q. So this is just 10,000 divided by 125,000. And just type that in. So 2 minus 10,000 divided by 125,000. And that's going to give you R prime of 10,000 is 1.92. Now, it told us that the price is in dollars, and this is per item. And that's pretty much it. Is it per item? Per unit. Same thing. So there you go. The marginal cost at 10,000 units is $1.92 per unit. Now, what that marginal revenue. What that tells me is that after the 10,000 and first unit will gain me $1.92. That's really all it's telling me. Excellent. Alrighty. I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.